Hello everyone. Today we are solving a new question on new concept. That is, we have to convert regular expression to NFA, then to minimized DFA. This questions comes around for 10 marks. So let's see what the question is. Write the regular expression, construct the NFA and minimize DFA. Actually here should be a DFA, minimize DFA for the language set of all strings ending with 00 over the input alphabet 0, 1. Okay, as I told you in the previous videos how to write the regular expression and how to convert to NFA. So I'm start solving it. Step 1, regular expression. What is the regular expression here? Ending with 0, and it can have any combination from beginning. Okay, so as I told you, any combination means the closure 0 union, this is union closure, and dot 0 dot 0. Okay, this is concatenation. Our step 2, we have to build the NFA. Okay, as I told you in the previous videos, how to draw the transition diagram of the NFA from the using Thompson's construction rule. Okay, so this is our closure. So first we will draw that this, it is epsilon. Now from here we have to draw this here, here. Now see, from here to here, this is epsilon, epsilon, and this is epsilon, and from here it is also epsilon. Okay, now see, it is concatenated, so it will continuation 0, 0. It is a final step. We will mark it with 2 circles. Now see, for solving this we have to give the state numbers, or you can give any names also, like A, B, C. I am giving numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now see, there are two ways. Means you can first convert this NFA to, it contains the epsilon moves, so you can convert it to NFA without epsilon moves, and then to minimize DFA, then to minimize DFA, but it will a very lengthy process. So what we will do, we will find the epsilon closures. Okay, now see how I'm solving this. What is epsilon closure? Epsilon closure of a state Q is a finite set of states, including that state also. In the state Q also, from Q we can move to different states with epsilon moves, means epsilon transitions. Okay, what is epsilon closure? I am repeating once again. Epsilon closure of a state Q is a finite set of states, including the state Q, and from that state Q we can move to different states but with epsilon transitions only. Okay, like see, for epsilon closure of 0, state 0, what will the epsilon closure? This state also Q0, Q1, Q2, Q4. Okay, because we are reaching these states using epsilon transition. Now see, this is also an epsilon transition, so Q7 will also come. Okay, I am showing one example. Epsilon closure of, I say 0, state 0 will come. From epsilon transition I am moving to 1, so it will 1 also come, 2 will come, 4 will come. From 0 with epsilon transition I can move to 7, so 7 will also come. Okay, this is a epsilon closure of 0, state 0 means the state itself and the different states we can reach using the epsilon transitions. Okay, now see, for this where we have to solve like this. We have to make a table x y equals to epsilon closure of x y of 0 and y of 1. Since here two inputs 0 and 1, y of 0 y of 1. Okay, now see, for this we have to start with a starting state. Okay, starting state is 0. So what is the epsilon closure of 0 x? As I told you here, 0 1 2 4 7. Okay, now how to solve this? See, in every state we have to keep this 0 and 1 and we have to see it is going to next state. If yes, then we have to write that state. Okay, now see, 0, if we are putting 0 there is no transition, so no. 1, no transition. Here we have, in the transition we have to write 0 and 1. I forgot about this. Now see, 2, if we give 2 state means 2 to 0, it will going to 3, so I will write here 3. Okay, I will write here 3. Same for 4, I am giving 4 to 0, there is no transition, so it will not come. Now see 7, if I give 7 0, yes there is a transition to 8, I will write here 8. Fine. Now for 1, 0 I am giving 0 1, so no it is not. For 1 no transition, for 2 also no transition, for 4 it is transition going to 5, I write here 5, and for 7 there is no transition of 1, so it will come single 5. Okay, now see, what is the next step? Our next step, we have to take the unique combinations here. Now see, 3 8, I have taken this combination. What is the epsilon closure of this? As I told you previously, epsilon closure of 3. How to find epsilon closure of 3? 3 to 6. Yes, it is going to 3 to 6. 3 will come. 6, 6 to 7. Okay, it is going to 7. Now see, from 6 there is a back here. It is also an epsilon transition, as you can see. So I will write here epsilon transition from 6 to means 1 it is going, then 1 to 2 and 2 to 4. Yes, 1 to 2, 2 to 4. Now see, for 3 we have done the epsilon closure. Now we have to find the 8. For 8 there is no epsilon closure, but yes 8 will come itself. Okay, now we have to solve this y of 0 and y of 1 for this also. For 3 there is no transition from, for 0, for 6 there is no transition of 0, for 7 yes it is there, it is 8. For 1 there is no, for 2 it is there, that is 3. For 4 there is no, and for 8 there is 9. As you can see, if I give 0 to 8 it is going to 9. That's why. And same for 1, see, 3, if I give 3 to 1 it will not go. For 6 no, for 7 no, for 1 also no, for 2 also no, for 4 it will go to 5. Okay, now see, 4 I am giving is going to 5, and 8 there is no, that's why I close here. Okay, now I have taken this combination, this is also I will take this combination. Okay, now see, for this, what are, if you see in the diagram you can find the epsilon closure. So try yourself by pausing the video. I'm writing the epsilon closure of 5 is 5 itself, 6 7 1 2 4. Okay, now see, if I give this 0, 5, from 5 there is no, for 6 there is no, for 7 it is 8, for same 1 no, 2 yes it is 3, and for 4 there is no, and same here 5. will come. Okay, try to solve it, it will come. Now see, I have taken this combination, look at this combination. Now see, this and this is same, this and this is same, and this is also same. I have taken here. What's the new? New is this 839 or 389. Your choice, you can make. Okay. Again, I will add this epsilon closure. You will come 8 itself. Okay, from 8 there is no epsilon transition to 8 itself only. 3, 6, 7, 1, 2, 4, 9. Okay, now see, if I solve this, what will come? See, if I give 8 the 0, it is going to 9. If I give 3, 0, no. 6, no. 7 also no. 1, no. Yes, 2 will come. It is 3. 4 will not come. Wait, I think I have done any mistake. Yeah. 8 for 9, 3, 6. Yes, 7 will come. 7 I have 0, it is 8. 8 will also come. And for 2, it is going to 3. And 4, there is no. For 9, there is nothing. And same here, if I solve, there is no only there for 4. And yes, 4 is there. So I will write a 5. Okay. Now see, is this a new combination? What do you think? This and these are same. There is only changing of position, but same, no. 839, 839, and I have taken a 839. So means there is no new combination there to solve here. This means we have to stop here only in for finding this table. Okay. Now what we will write? We will write assuming 0 equals to A, 38 equals to B, 5 equals to C, 839 equals to D. I am assuming this. Now see, what is the final state? 9. In this states, if the state contain 9, then that will be the final state. So see, in this it is 9, so that is the final state. We are marking this star. So since this is a final state, I will mark with this star to D. Now see, we are assuming and we have replaced this. So now what will come? 0, 1. I am building a table for this A, B, C, D. Giving 0 to this means we have to build using this now. 0 for A, it is 3 comma 8, 3,8 is B, so it is giving going to B. For 5 is C, going to C. Same for B. B is what? 3,8. For 3,8, y of 0 is 839. 839 is D star, means that's final state. I will draw this, and same C will come here. Again it will B, it will C, it will D again, and it will C. Now what is our step 4? Our step 4. Okay, you can write here replacing also, that's not an issue. Step 4 is minimize DFA. Okay, as you can see, this and this are same. Since A is a starting state, so I will replace C by A. Replace C by A. Okay, I can't replace A by C. I can replace C by A because A is a starting state. Now you will think these are also same, but why we can't this replace? Because this is a final state D and B is a non-final state, that's why. Okay, now I will draw again A, B, T, 0, 1. Now see, since we are replacing C by A, so in the place of C there will be A, and this C state line will get deleted from the table. Now see B, it is B, same D, D. Now this is our minimized DFA because we can't minimize further. So this is a final minimized DFA. Now we have to draw a transition diagram of this. Now see A, this is our starting state. I'm showing this arrow of starting state. I will draw B, I will draw D. Now see A is it's receiving 0 going to B, receiving 0 going to B, receiving 1 itself. Okay. B is receiving 0 going to D, 0, receiving 1 coming to A again. Okay. D is receiving 0 itself, receiving 1 coming to A. In this way we can find the minimized DFA from regular expression. Okay. Thank you.